Hi lads, in this video I'm going to go through how to do the 2018 Section B question 4 from higher level. It tells us the elevation end view of a torch are shown. The torch consists of a truncated cone A and a cylinder B, which is also truncated as shown. A 3D graphic of the torch is also shown. Part A, draw the given elevation end view. Part B, project a plan from the elevation. Part C, draw a development of the conical surface A. And Part D, draw a development of the cylindrical surface B. So to start with this question, I'm going to draw the elevation end view as given in the question. So the height is going to be 64. Let's move this down a bit. I'm trying to keep it as close as I can to the top of the page. It's going to be a diameter 64 for the outer circle. I'm going to draw my elevation and keep it close to the side of the page, so I have plenty of room to fit my developments in. So for my elevation I go across 35 and then I go a further 85 after that. And I take those two lines up. Focus so you can see, and now I'm going to begin to draw the actual outline of where the truncated part occurs in the cylinder. So we come in 15 and we're told it's at an angle of 60 degrees. Sorry, not from the very top. We draw our centre line in, which is going to be 32 mm up. So our centre 32, and it's for the smaller cylinder that actually occurs. So I go up 16 above that because it's a diameter of 32. And where that point hits my 15 mm line, I will go at 60 degrees then, and that'll give me that edge there. So if it's 16 above, that means it's going to be 16 below as well to give it a diameter of 32. And that line will go heavy across to there and there, and that gives us that little bit there left at the end. And then these 2 points join up here and here to give us our conical surface then as a result. So that gives us our elevation, and we take all of our heights across to draw in our end view. Make sure to keep my end view nice and close so I have enough room to fit in my developments to the side. So I take my diameter 64 on the outside, and you can see that when we're looking from this side we can see all of that outline there. I then have my smaller diameter 32, which is here, and that's going to appear dashed all the way around. And then I'll just go over the actual outline of it in lightly as well, so I can find my points where the touch, and I divide up my circle later on. And we then have our actual edge here that occurs, and that's dashed going across the page like that there. And that completes our plan. Now to draw our end view. When we look down, the cone is going to be the same shape again. Take all of our points down for now, what we have. And using our 45, just like when we were doing our orthographic, we'll take our widths down from here as well. So these 2 points here are my outside points of my cylinder, or sorry, my cone, and then these 2 lines coming across here, they are the cylindrical part. So I can connect these 2 together here, take that straight up, and connect these 2 points together here, and that gives me a conical shape in plan, and it just focuses there so you can see. And then that will go across, and my top point is my centre point at the top. There's my top point there, where they meet gives me this point here, which is the top point. As this is now cut here at an angle, we're going to see it produces a curve underneath. So at the moment we have this edge that occurs here, so this line here, that edge in plan is going to look something like this. So we take those 2 points down and take them across like that there. We have that outline there for now, where the actual edge occurs. Now it will extend out, but for now we just have that edge there drawn in, and now we need to project our points on our curve. So the curve will occur around this section here. So what you can do is you can get your 30/60 and just divide up your points on each side. And for the lower half, we'll just get 1 more point down there, and the exact same there side, we're going to get 1 more point out here. So I'll label them out. On the very bottom is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 there. So at the moment I have 0 and 10. I have 0 here and 10 here, and I also have 5 here. So I can take them across and label them now as well. So I have 5 here, 0 and 10 are at the bottom. What I have to do now is take 9 and 1 across to there. I have 8 and 2 across to there. 7 and 3 are extended out the rest of the way there. And then we have 4 and 6 there. And we just repeat the process like we would with any other point. We take them all down. So for example, 9 will come down there. Take 9 across. 9 hits there. So now I have point 9. 8 is the very outline. Take that down. Take it across. Take it over. Take this down. There's 8 there. 7 is on the same line as 9. So I just extend 9 out. And I take 7 down to meet it there. And then 6 comes down there. Across. And 6 is this point up here. Then I have 5. And then it's the exact same for 4, 3, 2, 1, and 0. So 4 comes across to there. 4 comes down there. Then I have 3 on that edge there. 3 comes down across. And 3 following it down will give me this point. 2 has already been taken down. 2 is on the outside edge here. Gives you that point there. And then 1 is taken down. Cross over to the same line as 3. And 1 goes down to there. And what that allows you to do is draw in that cut surface there as a freehand curve. And I get that shape as a result then. excuse me. And I can extend these lines out here, join the rest of the way around. And that completes my plan view. So now I have my elevation plan end view, which completes part A and B of the question. So part C then asks us to draw a development of the conical surface A. So A is that surface there. So we can see it's truncated, which means it's cut at an angle. And from the 2019 question, we've seen that if we extend our extreme generators there and there, we get a point along the central axis, and that gives us the top of the cone. So what we're going to do is we're going to draw as if it was a cone first before it's even cut. So because they're extreme generators, that means they're true lengths. So I can take that length of my compass, just take it out to there. If I just pick a point, for example, out here, I could just swing this arc here all the way around, and I could say that I'm going to start maybe up here. That's going to be my extreme generator at the end, for example, on this line here. So with that, we're going to have to step out a series of points all the way around, and to do that we divide up our our circle in end view into a number of equal parts. So by extending these lines out, we're going to get a series of points all the way around, and the distance between all these are going to be equal. We're dividing up into 12 equal parts. So that's all divided out there, and I can divide up in horizontals. So what I'll do is I'll start off and say this is A, B, C, just to change it around. D, E, F, G, H, I, J, K, L, and then M. So when I start with A, when I go the whole way around the development, I should end up back at A again. So that's how I actually count out. It's best to actually divide them up and label them, because it's easy to remember how many times you want to step it out. So for example, A goes to B, B to C, C to D, D to E, E to F, F to G, G to H, H to I, then on to J, K, L, M, and finally back to A there. And all of these points are all going to connect back. So they all connect back, and they're all divided out evenly. So what I've drawn out a development of a cone, and we imagine as if it hasn't even been cut yet. We haven't even dealt with the cut part. And then our last one there, and just label these as well. Now, the cut occurs along this surface here. So we can just see the straight cut across. So we just have a horizontal cut across there. If we were to stand the cone upright, it's a horizontal cut. So we already know this is a true length here and here. So therefore the distance from here to here or here to here is also going to be a true length. So we can take either of those, and because the straight line going across, the distance is always going to stay the same around the whole curve. So from there to there, it's always going to be the exact same. So what I can do now is I can draw in my actual truncated part here, where it's actually cut off, and draw it in nice and heavy. And then what I can do is I can start drawing heavy my outlines between here and here, and then I can draw in my fold lines then that occur in between, because all of this is going to be folded all together to form that truncated cone. So it's very important to actually include your fold lines. You have to show them in your actual exam. And then finally just the last few here before I move on to part D. And just to draw the outline. And there's in heavy the outline of my surface development for A. So I'll just put that there for the examiner as well. So surface A. I'll just put them beside of part C. And part A is going to be there, and then part B is your actual plan there. So that's the first three parts done. So the last part, draw development of the cylindrical surface B. So basically this surface here rolled out flat. So the same idea again. You draw it as if first that it's just a cylinder rolled out flat. So what I'll do is I'll just go down here, because I have enough space in this part of the page. Just move up my T-square so you can see. Move this up slightly. Yeah, you can see that. And I'll just draw a baseline. And an end here. I'm going to draw as if it's an actual cylinder rolled out flat. So I take my true length there. You can see my cylinder is 85mm long. So I take my 85 there. And just like the cone, I'm going to be dividing my sides up into 12 equal parts, using from 0, for example, all the way around to 10. And then extending these distances out here, 11, 12, and then this section here, 13. So for this actual question, because I have these little parts here where it goes around, I can actually include them in my measurement. So the distance between, for example, 13 and 0 isn't going to be the same as, say, 13 and 12. So I have to remember when I step it out, I only step out my actual division, so between 5 and 6, so I'm only going to be counting about 12 times going around. So I just take, for example, 5 to 6 here, and I can start excuse me, from 5 in the actual question. So if I go between 5 and 4, 4 and 3, 3 to 2, 2 to 1, so just put a dot to start here, just mark where 5 is there, so 4, 3, 2, 1, and the distance then is going to be a distance between 1 and 0, so I'm just going to step out for now and say that I'm going around to 13, I then go to 12, 11, I'm going to go to 9, because of the distance between 9 and 10 there that I'm going to mark out after, and then I'm going to go to 8, 7, 6, and finally back to 5. So 5, 6, 7, 8, 9, then I have 11, 12, 13, 1, 2, 3, 4, and 5, and between 1 and 13 is going to be 0. So I'll just mark out that distance. This between 13 and 0 is there. So we have that little 0 point thrown in now. And then also the distance between 11 and 9 is also a 10. So I'm going to mark that on my one. There. So I have all my points marked out. What I'm going to do with all these, I'm going to take them straight up. So all of these are going to be fold lines in between, but they're all going to have their own heights that I'll be taking as well. And I'll be using our plan to find that. So for example, all these lengths are going to be true lengths. So when I extend out, if I just move this down, There's the height for 4 and 6, for 7 and 3, for 8 and 2, 9 and 1, 0 and 10, and then I'm going to have for 13 and 11 here, and then finally 12 there, so I can add them in. I can have 12 there, and I can have 13 and 11 in between. Sorry, just one sec. Apologies for that. So, as I said, the height for 5, because that's my first point. I take my height 5 here, I apply 5 to there. After 5 is 4, I take my height there, I mark it up there. After 4 is then 3, 2 and 1, so I keep stepping along it. My height for 3 is there. Then I have my height for 2, and you notice it's gradually getting taller and taller. My height for 1 is that height there. 0 is going to give me my total height. So that exact point there. And then 13, 12 and 11 are also on the same height. So 13, 12, 11. And then we start to go eventually back down again. So all the way, to 10, it goes across to there. So I should have 0, 10, 12, 11, 13, 13, 12, 11, 10. And then 9 is going to go back down again. So 9 and 1 are on the same line. So instead of measuring the height, I go to 1, I mark it off 9, I go to the next one. 2 is shared, as you can see there, with 8 in my question. So I go to 8, mark it off there, next one, mark it off here, and then finally my last one is 5 connects back to 5. That'll give me all my points there. So I'm going to have a straight line between here and here, and then I'm going to have a natural curve progressing down, and this side the curve is going to progress back up again. And then just like with the cone, my end lines are drawn in heavy, base is drawn in heavy, and then I have all of my fold lines drawn in heavy all the way along here as well. Let's draw my last two in, just to complete the question out. And then I can just put in surface B, and that's part D of the question there. I'm going to put in B here and here to show my actual surface rolled out there. And that then actually completes the question. So hopefully that video helps anybody who's stuck on it.